Hello, everyone. My name is Juraci, and Michele, we are going to introduce you today to the Instrumentation Score.
I am Michele, head of product at Zero. I am an OpenTelemetry maintainer for the auto-injector.
And my name is Juraci. I'm a software engineer at OllyGarden. I'm a member of the governance committee for OpenTelemetry. I organize the OTL night in Berlin. So if you are in Berlin in a couple of weeks' time, you're all invited to OTL night. On my free time, I like to create content around observability or focus on OpenTelemetry under the brand Telemetry Drops. And you can find it on LinkedIn and YouTube. And for the next 30 minutes or so, we're going to talk about telemetry, bad telemetry. So we had a session yesterday focused on what is bad telemetry. And today we're going to focus more on Instrumentation Score. So what is Instrumentation Score? We're going to give you a spec overview. How are the rules structured? And some examples of those rules. And we should be having a few minutes towards the end for Q&A.
So, raise your hands, please, for me, if you have software running in production right now. Keep your hands up if you care about the software.
Oh, you don't? Okay.
So, do you have a clean conscience about your observability? Do you know what's going on? Sir, putting your hands down there, I appreciate your candor. So, when I actually go and try to explain people what I do for a living, usually I don't even say, observe what? And for the purpose of this talk, we are going to use a pretty commonplace definition of observability. Meaning, a system is observable if you can figure out what the hell it is doing and why it is doing stuff that it should not be doing. And the way that people actually go about observability is to collect data called telemetry so that you can figure out what's going on. And there are several ways of collecting telemetry. Both Juraci and I are very much in OpenTelemetry, so we're going to talk mostly about that. Technically, you can monitor things not only with OpenTelemetry, there are other projects. The way that you do it in OpenTelemetry is usually a combination of different instrumentations. For example, you may use the OpenTelemetry Java agent and add it to your Java application. All of a sudden, you have a whole bunch of spans and logs and metrics. Or you may go and code in your application against the OpenTelemetry API and create the spans just the way you like them, collect the metrics just the way you like it. And in reality, there's always a spectrum about a mix of automatic instrumentation and manual instrumentation. And after you have data, I mean, we're done, right?
Of course. Yeah.
We have observability. We're done.
Yeah. That's it. Thank you for coming. No, wait.
Talk is over.
Yeah.
Bye.
Now you start running things, and then you start from day one, and then you have day two. And on day two, you realize that you actually have too much telemetry, right? So you end up doing all of the things to instrument your applications. You use the auto-instrumentation agents and tools, and you end up having too much telemetry. And a lot of that is actually bad telemetry. And what is then bad telemetry? Like, bad telemetry is the telemetry that is not helping you fulfill the purpose that we've seen on the previous slides. Like, we cannot do things that we are expecting to do with telemetry. Or even worse, it may contain PII, or it may contain passwords and things like that. That is true. Like, that
Credit
exists.
card numbers, always a hit.
Yeah, but I think the biggest problem is really the amount of data. Like, up to 90% of the telemetry is just junk. And this is not a made-up number. This is a number that we saw from backends. Like, the leader of an observability company shared a few years ago that up to 90% of the data that they ingested was never queried, never seen, never used in anything at all. So that's just junk. That's just excess of data. And part of day two is we end up seeing bad telemetry, and bad telemetry everywhere. So I see bad telemetry everywhere all the time. And then we start thinking, like, am I doing this right?
The answer is, if you have the doubt, probably not. So let's start talking about this. Telemetry is amazing. OpenTelemetry is something that I honestly would do for fun if people didn't pay me to do it. It's great. But one needs to apply some judgment. And we are going to look at some classic issues with telemetry that make you regret your life until up to that point. A classic one is metrics cardinality. So metrics are great. It's a very compact way, very efficient to count things. Yeah? And let's say that, for example, you want to have an overview of the performance of your HTTP API in serving requests. So what do? You obviously go and read up the OpenTelemetry semantic conventions for HTTP and decide that what you really want to have is the HTTP server request duration. It's a histogram, you can calculate quantiles, you can do all beautiful things. By itself, just counting the speed of answering requests, however, is not enough, because not all the endpoints in your API, not all the operations are equally important. Not all the outcomes of your responses are equally important. If you make a very fast 500, it's not as good as a slightly more thoughtful 200, right? So you start adding a few attributes. And those attributes, they get values. And you start effectively creating more data points every time that you publish this metric. And the way that you calculate it in cardinality is that you effectively count the different combinations of key value pairs, and then you multiply them by each other, and in this case you get to 16. And 16 is fine.
That's a good number.
It's a good number. But then sometimes life is not perfect, and you still want to collect the HTTP server request duration, but for some reason you, instead of collecting the HTTP route, which is something that has low cardinality because you have only limited amount of routes, you start collecting HTTP path. And maybe, just maybe, your API is actually encoding variables during the path, which actually leads to a lot of different cardinality. And does anybody want to guess what the value is?
Oops.
The value is oops, yes. Mathematically, it would be infinite, but it's not nearly as fun a joke as saying my cardinality is yes. And when your cardinality is yes, this happens to your observability monitoring bill. It achieves escape velocity. Yeah? So this is one way that people get very sad at the end of the month. But there are more. For example, let's talk about logs. Raise your hands if you use logs. Cool, there are people that are not listening because literally every one of you is using logs at one point or another. Debug logs are cool. Debug logs is something that saves you in a pinch. Debug logs exist, to do debugging. In your heart of hearts, in the middle of the night, can you tell in conscience that you're emitting debug logs only when you're debugging?
Of course.
Of course, right? Naturally, this is what you say to the person that pays the bill at the end of the month. So I actually went and pulled some data. Let's have a little chat, a little heart-to-heart, about how often logs of different severities are sent to -0. And let's start with something relatively innocuous. Let's start with info. And right now, I would like you to scream out loud your guess about the percentage, and don't mind the friends in our rooms, they should know we have a good time. So, how much do you think is the percentage of info logs across the whole thing? 100. Nice. Excellent. Come on.
Louder,
Right.
louder, louder.
Can I get 40? Like, let's go auction style. No? It's actually 33%, or close to.
It's not too bad.
It's not bad. I actually thought way worse. And of course, the next one that we're looking at is warning, right? So what are we saying, people? 5. How much? 1%. Oh my God, that's nihilistic.
I would expect it.
More.
I mean, I hope for 40 or 50 at least.
You would hope at a solid double digit, right?
Of course.
I'm sorry to disappoint you. So nihilism, but grounded in reality. And then when you have spent enough quality time with OpenTelemetry, you know that there are several severity ranges. So info, warn, trace, debug, error, fatal. But do you think that every single log that gets into -0 is annotated with a severity number?
Oops.
And when you see me smirking like this, you know that in reality, the answer is going to depress you. So it's actually not. It's a 1/4 comes in. And this is not necessarily because of less optimal setups. It's just because sometimes the notion of a severity is not very meaningful. What is the severity of an access log? Yeah? So you could put it info, you could say debug, trace. In reality, it's not well codified, right? And since we were talking about trace, trace is like the tiniest severity, should be the one that like you really go mental and trace everything the application does. What are we saying, people? How much? 37%. Excellent. No, luckily it's actually a pretty tame 1%. And now, people,
This is all errors now, right?
we are down to 2 severities. One is debug, and the other are the 2 red ones, errors and fatal. So please state your faith in humanity by telling me what is the percentage of error logs, error and fatal. 1%? How much? 6%, 2%.
6% is a good guess. I would go with that.
It's a good one. I would actually go for it. In reality, no.
It's 0.
It's not technically 0. It is 0.4, and Excel in its infinite wisdom said, screw that, and told me it's 0. And this is what happens really in production. And then when you go to your engineering manager and to your CFO, this is what happens in their heads.
I can guarantee you the music goes after goes out of your mind after 1 week.
So if there is something that you bring along with you from this talk, is this nihilistic motivational speech about why you should care about your logs.
Yeah, so that's bad telemetry, right? I mean, this is. I think we all kind of can agree that debug logs in production is a bad idea. Like we're paying for something that it's supposed to be only for debugging purposes. It's okay to have it for a day or 2, but it's not okay to have it like forever. The other example that I want to bring to you today is this one. So this is a noisy internal spans. So when people ask me, how should I, so I understood OpenTelemetry, so I'm ready to start instrumenting my services. So now what? What should I do? What I tell them is, start with the boundaries. Like instrument your boundaries, instrument your server, and then your client. And if there is something that is very important in between, then you add a span for the internal, like an internal span. But sometimes, like in this case, so this is a real trace from a real system that we run at OllyGarden. So our services, they follow names of birds and plants and things like that. So this is the hummingbird service. And we have a lot of spans in between that. And that is a service that we coded. In the very first version of the service, we wanted to understand exactly what is happening there. So I have like a one span representing Bloom filters, and then add to the CMS and blah, blah, blah. So that was very useful at the very first version of Hummingbird. But now it's running stable for some time. And we don't need all of that right now. And it's still running production. Like, we're going to fix it, but it's still there. So, and that's bad telemetry, right? So this is another example of the things that we know that is bad, and it's running in production. So, and I guess with that, what I want to say is that the bad telemetry concept is fluid as well. Like, so what was good telemetry at the unstable version of Hummingbird is not good telemetry. It is bad telemetry now that Hummingbird is stable. So that dimension is, the time is a dimension on the concept of bad telemetry. And that's the cue to the instrumentation score. So what is then the instrumentation score? The instrumentation score is taking what he said and what we agree that is bad telemetry and encoding all of that knowledge in an open spec, on an open database. So the instrumentation score is a knowledge base where we, people from the industry, we people who've been doing instrumentation for some time, we can agree on what is good and what is bad telemetry. And we encoded that as part of the instrumentation score. So those are opinions, and it provides a guideline for people to understand what is good and what is bad, and why, right? And it's a score because then we can compare services and use those numbers to prioritize the fixing of the bad telemetry. So perhaps if I see that a specific service is a very low score and it's critical for my application, for my services, then I should fix that one first. But if the score is not too bad, or if the score is bad, but the service is not critical, then I perhaps should not fix that one. Now, how should I use it? And what are the tools that are available for me as part of the instrumentation score? So instrumentation score does not provide any tooling. It provides the spec. It provides the knowledge base. So you use the knowledge base perhaps to tell your folks, your engineers, what is expected from them in terms of telemetry. Like, what should they do? What should they not do? So this is one thing. The second thing is, something that I've been seeing people doing as well is using the instrumentation score as context for your coding agents. So perhaps you can have the instrumentation score local to your machines, and you launch a coding agent, and then you say, use those rules to help me do good telemetry. We can base that for your own instrumentation guidelines. So use that as a base, and then add your knowledge, your corporate knowledge, your internal knowledge as part of your internal instrumentation score. And perhaps vendors, we could implement tools that can tell you what is the instrumentation score for your individual services. Now, a short overview of the spec. So the spec was built. The very first step was we looked at prior art. So what exists out there in terms of scoring? What exists in terms of measuring quality? So we looked into CVSS, we looked into Google Lighthouse, we looked into SSL's lab server test, and others. Right? So and we picked a few things from all of those, from that prior art, and implemented as part of the instrumentation score. It is heavily opinionated towards OTel, so we don't care about things that are not OpenTelemetry. Of course, telemetry can be generic, but if we have to pick like an angle, that's OpenTelemetry. That's when we can make an opinion. That's when we can make it non-generic and applicable in a very easy way. So if you are using OpenTelemetry, that applies to you. That's it, period. Again, it's a numerical value between 0 and 100. The idea is you can, those numbers are portable because they're part of the spec. You can implement, different implementations should get to the same number, and you can compare services that way. There's no, for this service I don't care about this rule. No, every service has to care about the same rules. If you don't care, that's fine. Your goal is not to get to 100. Your goal is to get to a good range. So don't go for the number, go for the range. Each rule has their own impact levels, and we scope the rules per service name. That's where being opinionated in OTel helps as well. So we care about OTel, we focus on OTel, and that's why we can say, service.name is a semantic convention. Let's scope the instrumentation score per service. So one example of the instrumentation score, so we have a list of possible points, the maximum score that you can get, or the maximum points that you can get, and then we calculate what are the number of points that you got for a specific service. We divide one by the other, and then we get into the final score for that. So like the formula is that one, but the spec has this example that is easier to follow, perhaps.
Now, how do these rules look like? They are designed to be easy to understand and easy to implement. We have an identifier on top. You will see that the type of telemetry it applies, which we call signal in the industry, is on top. And then we have a sequential number so that we can add more rules without having to think too hard about abbreviations, because naming is really hard. And then we have a description to give you an idea of the kind of excellent behaviors that we've seen. And then we go deeper in the rationale, where we try to explain why something is not necessarily a great idea and you should look out for it. Then we repeat ourselves with the metric, because yes. And then provide a way to calculate the way. This is the most important bit, is the one that tells you what the logic is. Some of them are really easy to query from a database. Some of them are really easy to implement in a stateless fashion in, for example, your OpenTelemetry ingestion pipelines. Some of them are a bit more complicated. There is potentially some overlap with things like AutoWeaver and the live check, and there were some cool talks like the one of Ludmila at the Observability Day. And then the impact, so that you know that if it's important, then maybe you should care, and in other cases less. And it's going to impact your score less. And since we're talking about impact and score, instrumentation score at its very core, and it's a bad pun, and I do not apologize for it, It is a signal in itself. It's a signal about your signals. Treat it as a meta signal, if that helps you rationalize it. Juraci already said it. It's not about hitting 100%. This is not the PlayStation trophies. You're not getting platinum where you get to 100%. You should actually have a very pragmatic discussion about how close you want to get, which range. Something like 75%, something like above 50, and be pragmatic about it. Perfect is the enemy of good. Fixing all the instrumentations out there, it's not easy, and it's going to feel sometimes like a game of whack-a-mole. And going for perfect will probably burn you out. So don't do that. Focus on being opportunistic in your improvements. There is a lot of stuff that you can do really easily with things like the OpenTelemetry transformation language in the collectors, just a little bit of ugly YAML, and then your life gets better. Or with the filter processor, which is also OTTL. So you have also ways to actually fix and improve your instrumentation without touching the applications, touching the instrumentations. You can go and in the pipeline, massage it a little bit. And now we are going to play a game. And the game is going to be a fun one. Let's go and figure out what our collective observability score is. And this is based entirely on trust. So, we're going to know we hit 0. There is a calculator available. And we're going to start from the top and go through a few of the rules. And raise your hands right now, please, for me. And then when there is a rule that you feel your telemetry doesn't satisfy, then you put the hands back. And we see how fast we go to. So hands up, please.
100. We all have 100 points.
So do you have service name everywhere, sir?
I have in every single service, every single telemetry point. No,
every single?
I think there's one that may not have it.
I actually am missing it on some instrumentation metrics. Ooh, the microphone. So for example, it's pretty common when you're collecting metrics from Kubernetes not to have a service name. So we're going to struct that one. And since we're talking about Kubernetes, there is one attribute above all others that is truly important, is the k8s.pod.uid. This is something that you need to put in your SDKs somehow, like in downward node API or many other ways. All the rest you can fit in through collectors. Do you have it everywhere?
I suppose, yes. No, I think it might be missing to some of my workloads.
In Industrial, we have it everywhere because it's really important. But already you see that the score is going to be down. And something that is very interesting is in OpenTelemetry, there are many places where you can put data, you can put attributes. For example, service name is something that you put at the resource level. It describes where telemetry comes from. If you put it on the span, it's not great. That's not where it belongs. So sometimes it's easy for the telemetry, the attributes, to be stored at the wrong level. And the other day, I found out that in our internal monitoring, for some reason, we actually got the service instance ID at the wrong level, so I'm going to strike it.
And this is real. I mean, we've seen the same kind of issue.
It is. Sometimes it's a bit hard to get it right. And since we're talking about service instance ID, which should be the unique identifier of a component in a replica, so it feels kind of a bit like Kubernetes pod UID, but the granularity is different. You should have it ideally on everything where you have service name. In reality, this is where we all go with our hands down because almost nobody does that.
No, that guy does have it.
My God, you won the game. We have a winner. So, what do you take away from this little exercise? That no telemetry is pristine, but a lot of telemetry can be useful. Don't get depressed if all the things went right. A lot of these are pretty easy to fix, and they provide a material improvement in your observability experience.
And again, everything that we have there has a purpose, right? So there is a rationale on why this is important, and we have the reasons, and then you can, of course, you can say, well, that's not very important to my case, so you can ignore that one. It's not going to improve your score if you ignore it, But you don't have to have 100%, or you don't have to have.
You should not. Nobody can have 100%.
So yeah, I guess this is where we wrap up and do the key takeaways. And I think the first one is, of course, we need telemetry, right? So no telemetry is bad, so having no telemetry is really bad. But too much, or the easy button that we press to get some telemetry for our applications, that can generate a lot of telemetry and a lot of bad telemetry as well. So bad telemetry meaning not only too much telemetry, but yeah, so start with auto-instrumentation. So use auto-instrumentation by all means to get telemetry out of your applications, to understand what it's doing. But then go back there and start pruning things that you don't need. So you end up with better data, better telemetry from your auto-instrumented services. So yeah, because having too much telemetry is just bad. We've seen why. And what is good telemetry today might not be good telemetry tomorrow. This is one of the examples that we've shown, that time is one of the dimensions in determining what is good and what is bad telemetry. And if you need some help in telling what is good and what is bad, refer to the instrumentation score. We can help you in understanding, like having a baseline of what is good and what is bad. We can help you make the right calls when you need to make them. And I would like to ask you to tell us your bad telemetry stories. Like, what have you seen in production that you regret seeing, like that you should not have seen? Tell us your story.
You find us in many places. We are in the Instrumentation Score GitHub organization, where you can go and propose rules, and we can talk about it. You find us on the CNCF Slack channel, Instrumentation Score. You find us on LinkedIn. You find us in a bunch of places. Come play. Let's gonna have some fun making better telemetry for ourselves. And this being said, there is a microphone, and we're looking forward to hearing your questions. Don't be shy.
Don't be shy, yeah. The mic is open for singing as well, so. Are you want to sing?
Yeah, because if you're not asking questions.
Yeah, can you ask there? I'm sorry, but. Hello, darkness, my old friend.
Yes.
If we, for example, you mentioned the service name ID. If that one is coming from the serial instrumentation, why do we expect people having that problem? You mentioned before that many users having that issue. Are they putting there on? Are they removing them somehow, or are they moving to the data point level, metric level, or?
The service instance ID is actually generally not set by the SDKs on their own. It's actually, there is a specification OpenTelemetry about how service instance ID should be calculated, but it's not implemented in the things called resource detectors. This is something that it's actually relatively simple to fix in OTTL, in your collectors, but how you should be calculating the service instance ID actually depends on where you send telemetry from. If you do service instance ID on Kubernetes, that could be the Kubernetes pod UID. Although, if you have multiple processes in your containers in the pod, they may have different service instance IDs, and then the collector cannot tell them apart. If you're running on ECS, a good start is the task ARN. But again, if you have multiple containers and each of them have processes that emit telemetry, then you should not be merging them. Yeah? So in reality, there are some things in OpenTelemetry that you should be doing, but it cannot really be automated.
Yeah. So one classical example is like Python applications or Ruby applications where you have like Unicorn and Passenger and things like that that manages the threads or the workers, and each one of those should have a service instance ID on its own, because that is representing the actual process, like the actual source of telemetry. But so that's why at some points, like the collector cannot determine what is the service instance ID for the things that it's been receiving, right? So the service name is not identifying for that specific case.
Okay, thank you.
How do you deal with duplicate tags? We've got about 60 tags on every pod, and it's customer underscore ID, customer ID, namespace, account ID. All of them are the same value, or even better, they've got a postscript or a prescript on them. And I look at all 50 of them, and there's only about 4 that differentiate things. So how do you deal with that sort of insanity?
So one good way of solving that is by defining your own rules for telemetry. So the person just behind you can answer the question about Weaver. So you can use Weaver. No, so you can define, so in terms of the customer ID and so on and so forth, like you define that all my applications should follow this pattern here. So the customer.id, for instance. And you can enforce that by using Weaver. So you can create your own instrumentation score internal to your company saying, I require customer.id across my telemetry. And that can be implemented by tools like the Weaver. I'm sorry.
Yeah, I'm sorry, you caught me off guard. I have a question. You folks have some opinions about good telemetry, and they are awesome, and I would love more opinions in observability space around them. Do you have any feedback to semantic conventions? Like what should we do there better? Are there bad practices that we kind of follow systematically?
Yeah, so I think I can go first and then you.
Let me start.
Sure, go ahead.
The semantic conventions are, hands down, the best part of OpenTelemetry.
I agree.
There are many systems that over the years we have used to collect telemetry. None of them came with an extensive dictionary of how to describe our telemetry. The gentleman was telling us about the Tower of Babel, that is any instrumentation out there. Like when you have enough people in a room, like if you have 3 developers, they will find 5 ways of calling an S3 bucket. That's a fact. And you need to find a way to describe those. And the semantic conventions give you an agreed upon, well thought out way of describing telemetry. The world needs exactly 1 set of tags to describe HTTP requests, no more. 1 set of metrics for Java garbage collection, no more. And the semantic conventions do that. Now, this being said, the semantic conventions are complex because there is so much technology that needs to be described. And there are some gaps in the way that we talk about semantic conventions. For example, when we were talking about HTTP, right? And I was talking about access logs. Now, technically, you may want to structure your access logs very similarly to the way you would structure a span. Because that is like kind of just a span without the trace ID and the parent ID. You technically, according to semantic conventions, cannot really do that. Those are HTTP span attributes. And understanding on which type of signal you should be using, which type of attributes, is not as easy as it could. Some things that are not necessarily a problem of the semantic conventions themselves, but they reflect on semantic conventions, is the fact that a lot of SDKs are not going as hard as they should in automatically annotating your data right. And that kind of sucks. We're talking about service instance ID. Wouldn't it be nice if it just worked? It's very important, it should work, right? Maybe you want to
I want to add, perhaps say something else there, that is not all, so some of those opinions, they are kind of clear to us, like this is bad. Other ideas, they are not very clear. I have strong opinions about thread.id. I know that Dan likes thread.id. Well, not that he likes, but he had a problem in the past that he needed the thread.id to debug an asynchronous Java problem in some situation. So my opinion is different than Dan's, and that's why Instrumentation Score is a separate project, because that's a place where we can say, so what are the opinions that we should be having as an industry? And then funneling that feedback into semantic conventions. So I have some of them already, like thread.id is not one that I'm going to propose, but perhaps the host.ip and host.mac, perhaps they should not be part of the resource attributes. Like perhaps they should not be automatically captured by auto-instrumentation agents, right? But so that appears to be something that is common sense to us now, but it wasn't so clear to me 6 months ago. So eventually, the short answer is eventually we're going to funnel that feedback into the semantic conventions back.
And also purely technically, I mean, I said semantic convention is the best thing, hands down. They were not the first. Some of the semantic conventions you see in OpenTelemetry are coming from open tracing. Very few, but they're still there. Some are coming from the Elastic Common Schema. And there was an enthusiastic proliferation of semantic conventions to the extent where there is a few that are really solid, like the HTTP ones, the RPC, the database, like, nice. Others are in different state of stabilization to the extent where it is a bit difficult to say, okay, we commit, and now I feel good about implementing the Gen AI namespace instrumentations because they evolve a little fast, and the desire to have stable semantic conventions is outstripping the speed at which the project manages to crank them out.